Now that we got to know about what the register is in general CPU processor, let's think about the nature of the register in another perspective. So there are two viewpoints of the processor. First one is hardware and the second one is software. As you can see in the slide, this picture I show you nothing but the silicon chip in the foundry. This silicon is made of the transistor or capacitor. Based on this hardware viewpoint, there's nothing you can do control silicon from software perspective. In order to configure these silicon chips from software perspective, we need the interface. That interface is called the architecture. The architecture is the interface between hardware and software. Now let's think about the processor from the second perspective, that is based on software. The software viewpoint and processor can run the machine code. The machine code is lowest in code that the processor can perform. But in order to check whether the processor run the machine code in correct manner, what we are going to do, we should check the value of the register before, after instruction. So I can say that activity of the debugging is to check the value of the register before running instruction and after running instruction. That is why understanding how the register is organized is important. Now that we got to know about the nature of the register, let's think about the register in the RISC-V architecture. As we discussed in the previous lecture, we have the general purpose register in RISC-V architecture. And we have another register. Another type of register is CSR register. The main difference between two registers is that the general purpose register can store any of the temporal data. Instead, CSR only contain or store the predefined data. For further analysis, detailed analysis of each register will be go ahead in the next lecture. So at this time, I want to highlight the feature of the register. Now, let's take a look at the example assembly instruction in the RISC-V architecture. And this is a list of the assembly block inside the process 1 work. That is the K API in the Linux kernel. And every assembly instruction use any of the general purpose register. So please take a look at this. Add assembly instruction is together with SP register. SP is one of the key register in RISC-V architecture among the several general purpose register. And as for this instruction used to store the data into memory area. The memory area is stack area in the assembly block. As you can see, S0, S1, S3, S5, these are one of the general purpose register in the RISC-V architecture. After we run this instruction, the value of this register will be stored into the stack area in this process. And please take a look at this. This is an add assembly instruction. Add assembly instruction is together with the S0 assembly instruction. in the context of the syntax of assembly instruction, this register is called destination register. So this register is called the source register. The point is every assembly instruction used any of general purpose register. That is the key point. So it is important to figure out how the registers are organized in the RISC-V architecture. Now that you understand the characteristics of the register, the next lecture you're going to learn about how to run about the register in effective way.